Humans are wired to look out at the horizon and see endlessness. From our perspective, the sheer physical size of the planet seems to provide an infinite supply of raw material to fuel our growth. But that scale is an optical illusion. Beneath the sprawling landscapes lies a highly restricted, strictly finite life support system. This diagram shows a volumetric comparison of Earth's water. The massive sphere represents everything in our oceans, but 97% of it is heavily salted and unusable for terrestrial life. That leaves us with a tiny 3% sliver of freshwater to keep every land-dwelling organism alive. The ground beneath our feet operates on similarly brutal math. To generate just one thin layer of fertile topsoil, the dirt required to grow our food, solid bedrock must weather and break down over thousands of years. Human survival relies entirely on just 5 tightly constrained pillars: land, soil, fresh water, naturally occurring vegetation, and the wildlife that populates it. Earth functions as a highly calibrated machine. Depleting any single one of these pillars risks stalling the entire engine. In its undisturbed baseline state, the global ecosystem functions like a perfectly wired circuit. Each natural asset relies completely on the output of the one before it. It starts with the land itself. The physical topography and climate conditions dictate exactly how and where that slow-weathering rock turns into soil. That razor-thin layer of topsoil then combines with our scarce 3% fresh water supply to act as an incubator for plants, shrubs, and forests. Once established, that natural vegetation becomes the engine of the entire system. Plants produce the oxygen, structure the habitats, and generate the food required to sustain indigenous wildlife. This flowchart illustrates the complete biological circuit. As animals and insects consume vegetation and maintain the food chain, they cycle nutrients back into the dirt, keeping energy flowing in a stable, unbroken loop. In this closed system, absolutely nothing operates independently. The resources form a completely interdependent web. When we introduce rapid population growth, heavy industrial expansion, and mass resource extraction, we introduce violent shocks to that balanced loop. The first critical failure point is usually the surface layer. Through aggressive deforestation and livestock overgrazing, the protective canopy of vegetation is rapidly stripped away, leaving the bare earth exposed. Without deep plant roots to anchor it in place, that nutrient-rich topsoil, which took millennia to form, is quickly swept away by wind and rain. That eroded dirt and agricultural runoff flows downward, choking rivers and lakes. This immediately degrades our already limited freshwater supply, with severe pollution and scarcity. Looking back at our ecosystem flowchart, we can trace the final stage of collapse. The connection between vegetation and soil snaps first. Without clean water or plant cover, wildlife habitats are destroyed, turning the biological nodes red before the entire food chain shatters. Human activities like open-pit mining, industrial waste dumping, and illegal poaching act as heavy accelerators, striking multiple weak points in this chain all at once. Degrading even one natural resource triggers a cascading, systemic failure across the entire life support network. Halting this collapse requires a shift toward active stewardship, framing conservation methods as mandatory system repairs. This cross-section illustration demonstrates one of those repairs in action. By cutting stepped levels into a mountain for terrace farming or planting linear shelter belts along fields, we create physical engineering hacks that trap descending water and literally lock the topsoil in place. Afforestation, the mass planting of new trees, serves as the ultimate anchor. It simultaneously reconstructs the physical land structure and restores the missing vegetation baseline. To protect that extremely fragile 3% freshwater supply, communities employ rainwater harvesting to capture precipitation before it's lost, while industries implement large-scale water recycling. At the biological level, national parks, wildlife sanctuaries, and anti-poaching laws operate as structural fortresses, keeping the upper levels of the food chain intact. These targeted, deliberate interventions are the only proven mechanisms we have to arrest the domino effect and force the chain reaction into reverse. The underlying mathematics of our planet are unchangeable. Earth's vital natural assets are strictly finite, completely interdependent, and cannot be artificially manufactured. Sustainability is now an absolute operational requirement for maintaining the global ecosystem. Ensuring human survival for future generations depends entirely on abandoning the illusion of infinite abundance and accepting our role as permanent stewards of a fragile machine.